The end is in sight. You sure don't want to not turn in a project. We'll meet on the 9th. That's a Thursday, right? And your projects are due by the end of the day Friday, by the close of business, by midnight.
So if I just make a PowerPoint of the pictures that I took and send it to you, that's fine, email it to you?
As long as you meet all the criteria I specified in my syllabus,
Yeah.
or my addendum or whatever it was. A lot of times students will give me a photo project and it will be incomplete. And at that point, I will have to deduct points. I think I told you.
If I remember correctly, you want what we see in the picture,
Right.
the date it was taken, and
Right.
where it was taken.
Right.
Okay.
So don't forget to include that. So, yep, that would be great. I will look forward to that.
Okay.
By midnight. Now,
I'll
one
probably turn it in tonight.
of the, what's that?
Probably just email it to you Thursday.
That sounds good. One of the things I didn't explain is like, so say the 10th comes and goes and you didn't turn in something, but you have something to turn in later, and it's your only project. Well, I'll cross that bridge when I come to it. I'll probably start deducting like 5% each business day it's late or something like that. So this is to say, don't not turn it in, but just know that points will be deducted, and I'll be fair across the
So
board.
business day, which would not include Saturday and Sunday.
That's true, but if you turn it in Monday, you've lost 5%.
That's fine.
So yeah.
Does that mean there's already like a folder of it on the website now? So if we're done, we just turn it in now?
I don't have a Dropbox or anything, but
Okay.
kind of he was just saying
Just
to
email
email
it
it
to
to
her.
me.
Okay.
And if you have a Dropbox like the cloud storage or whatever, you can just take a link and give me the link, and as long as you don't delete it, I can see it and you can see it.
Okay.
So yeah, I think Google Docs lets you do that too.
Mm-hmm.
You just throw it into Google Docs and then.
I don't like
share it.
anything Google does.
You don't have
better
Google
than
Docs? Do you have
anything anybody
Dropbox?
else does.
Yeah.
I don't like the Google Docs at all.
Yeah, I've heard that.
Really, I love Google Docs.
Yeah. So any.
I have to use it though.
It's good. I think it's good. Okay. So, on to severe weather. And I don't know if I told you, I probably did, that I've actually looked at a textbook just for severe weather, because I'm like, that's what you guys take this class for, right? But couple things. When I found the textbook, basically it went into all this stuff that was like over my head. It was a bunch of physics and stuff, calculations. And I guess the other thing is to understand severe weather, I think you need to understand the other stuff we've been talking about. Because, and actually I have it to hand back to you, in your quiz last week, you told me the most unstable air mass is maritime tropical, moist and hot. Okay? So meet moist and hot air rising. Right? I think it's funny because the thunder, of course, is the audible part of the lightning, right? So thunder doesn't kill, but lightning does. And we'll talk about you guys know that you see the lightning bolt and then you hear the thunder. It's delayed depending upon how far away that is. So we'll kind of talk about that rule of thumb. Okay, but a thunderstorm just basically means we talked about cumulonimbus cloud, so you have a cumulonimbus cloud doing its thing. It's precipitating. You have a thunderstorm in action. So you can have lightning and the sound part, which is thunder. You can have heavy rain, hail. Remember, hail is part of cumulonimbus clouds things, right? You can have tornadoes dropping out of your cumulonimbus cloud. Okay. So the thing with the cumulonimbus cloud, first off, it has a lot of what we call vertical development. Okay, it's a cumulus cloud. It's puffy, and it goes to the tropopause, the top of the troposphere. Goodness forsake, right? A lot of vertical development. And so in order to get that vertical development is very unstable. Okay. The other thing is, I mentioned moist air is very unstable. The thing about water vapor, when it goes from a gas to a liquid, it releases heat, latent heat of condensation. And so honestly, basically as it's condensing, it's bubbling over, so it kind of feeds on itself. If you have water vapor condensing, you have one of these that basically it's what we call kind of a positive feedback sort of thing. So cumulonimbus clouds, thunderstorm clouds. So I'm going to go out. I think this is a video.
Video.
He might. So that's one of the things I kind of want to get out of this unit or this chapter on severe weather. The next chapter, we're going to talk about hurricanes, which don't know about you, but I probably don't need to know about hurricane safety as much as I do about tornadoes and lightning and that sort of thing. So thunderstorms are cumulonimbus clouds, and to get cumulonimbus clouds, you need instability. To get any cumulus cloud, you need instability, but to get that vertical development, you need a lot of instability. So we talked about orographic lifting, that's lifting with mountains, okay? And there's also frontal lifting, we call it frontal wedging, I think. That's the lifting associated with usually, well, both fronts. And I think we talked about cold fronts have an abrupt lift, and warm fronts kind of have that overrunning, test question, right? Sort of thing. But lifting is required to get it going. So I was looking at this at my office, and you're like, so where do we form? Where do we fall? Well, we're kind of yellow here. Yellow is looks like it's 50, and I didn't check it, really track it down, but relatively speaking, notice down here that we're at 100. Okay, over here it never rains in California. Okay, thunderstorm-wise, they don't have it going on, which kind of surprises me, you know, because they could have orographic lifting and all that stuff. Okay, I think that their air masses. Remember, we talked about source regions, and you know their air masses. This, of course, would be maritime polar. Okay, and this down here would be maritime tropical, but it doesn't really hit these guys. It hits these guys. Okay, and of course, speaking of maritime tropical, right, we definitely have maritime tropical on either side of poor Florida. They have their issues, don't they? Okay, so warm, moist air needs to rise in order to give you a thunderstorm cloud. But with that said, we don't have mountains around here. Most of ours is that frontal lifting. A cold front, most especially, gives us a cumulonimbus cloud. All right, so we're going to talk about types of thunderstorms. So when I say thunderstorm, think cumulonimbus cloud. We're going to start out with a simple one, kind of an isolated one. As you guys know, maybe sometimes thunderstorms come in buddies. Okay, we'll talk about that coming up here in a minute. But just to start out with just a simple, what we call air mass thunderstorm. And so they don't last very long, and usually they're not severe. That's the word tame. Okay. And these often can happen, like it says, in the middle of the day. They kind of do their thing and they move on. Where life really gets interesting is two things. One is if you have these multiple cells doing their thing. Okay, there's two types. There's a squall line of thunderstorms. Okay, and then there's this big blobby thing called a mesoscale convective complex. Lots of them. The other thing is supercells, and these are neither of those. It's just an isolated air mass thunderstorm. Okay, but what's good about it is it goes through these same three phases that the other cool cells go through. Okay, so air mass thunderstorms have a cumulus stage, then they move on to a mature stage, and then they end their lives as a dissipating stage. And as we talk about supercells, they do the same thing. They have a cumulus stage, supercells do, they have a mature stage, ouch, and then they have a dissipating stage. Okay, so let's kind of look at this simple air mass thunderstorm, how it looks in those three stages. So kind of from left to right, it's hard to tell if the one there on the right actually is raining at the bottom. Okay, you're like, I don't know, it looks nice and milky white. I can't see if it's precipitating, right? But this one, what's that?
That's dark enough, I can tell it's raining.
It looks dark enough. It looks like, yeah.
Especially at the bottom.
Yeah. I'm guessing cumulonimbus. I'm guessing we're getting some
I
precip.
mean, it's not super tall like you would expect, but that one that's probably at least getting ready to rain.
The one thing is, and we'll talk about this, have you ever seen like the storm clouds kind of flatten out up there? We call that actually an anvil. And this one actually, you know if it has an anvil, it's like hit the tropopause, top of the troposphere, because that's what makes it flatten out. The other thing though, but along the lines of, can you see how crisp that one on the right is? It's crisp and crunchy. If you go to the National Weather Service spotter training, they'll tell you the crispness means that actually it's on its way, it's maturing. The crispness means it's maturing. It's kind of new to, it's kind of punching, okay? It's crisp.
So it's about to start its vertical growth.
It is in the midst of, yes.
Does that happen really fast?
It can, depending upon the
I feel
instability.
like I've seen that happen,
Mm-hmm.
but
They're kind of, it makes you want to get out your camera and
it
start
seemed like
taking
it happened
video,
too
right?
fast for it to actually be
Yeah.
what I thought it was.
But have you seen, and like on the way here, I was looking outside, and those clouds are not crunchy. Those clouds are kind of diffuse. They're kind of, right. Now this over here, they're calling just fair weather cumulus clouds. Of course, not cumulonimbus, cumulus clouds. They look kind of like they're middle, sort of maybe, well, they're just calling it not altocumulus or cumulus. Okay. All right. So let's look at those 3 phases of a thunderstorm cell. And like I said, those will be the same phases that all thunderstorms go through. So they have this stage where they're developing called a cumulus stage. Not so surprising, we have a cumulus cloud there. Okay. Now, the 3 stages, cumulus, mature, and dissipating, are distinguished by, do they have an updraft? Do they have an updraft and downdraft, or do they only have a downdraft? So the red line, that's your updraft. So if you were standing under this cumulus cloud, actually you'd feel a little bit of, okay, like that sort of thing, maybe not. Okay. We do have the lifting condensation level. And it looks like it might be kind of crunchy, so we were talking about that's probably developing. So this flat bottom, that's the elevation, the lifting condensation level, the level that you need to go to in order to get reach a temperature where whatever moisture you have in there starts condensing from a vapor to a liquid. Okay, so cumulus stage, updraft. Okay. Cumulus stage, and this doesn't have to happen in the cumulus stage, but the word entrainment means, and actually, how do I say this? Well, anyway, I was going to kind of liken it to using a conveyor belt, like if you're transporting things, you have a factory and they're kind of getting work done from here to there. Okay, so entrainment is actually, and I think that's a process. Dry air is getting kind of entrained at the edges. So entrainment happens, I'll choose green color. Entrainment happens here at the edges. So dry air is moving in, okay, from the edges, and that can happen there then is you can have some of that liquid water that went ahead and condensed, it can go ahead and evaporate. And as that water evaporates, 2 things, like this says, you have a bit of cooling, which kind of douses your instability. But the other thing is you form a multiple size, a lot of different sizes. So in here, these are, I'm trying to kind of draw big ones and little ones. Remember we talked about the collision coalescence process? Okay, and we said the collision coalescence process requires kind of an assortment of liquid water droplets up there. That's what entrainment does for you. So that's entrainment. All right, does it look different? Looks taller. Looks taller. You can kind of start to see it flatten out at the top. That top must be the tropopause, right? The other thing is now we not just have an updraft, but now we have a downdraft. This is the mature stage. And all of your nasty stuff that can happen will happen in the mature stage. So on a test question, if I put, what stage does you get lightning? Okay, mature. What stage do you get tornadoes? Mature. Hail, mature. So basically you have an updraft and a downdraft. Okay. Now with these simple air mass thunderstorms, these simple air mass cumulonimbus clouds, basically this won't last very long. This mature stage won't last very long. It will rain itself out. Okay. So a few things. I think it's on the next slide. So there's a word for that topping out, and you've probably heard it before. And actually, when we talk about severe weather, this isn't a severe one. I mean, lightning doesn't make it severe, even though lightning actually is what kills people. Okay. But in severe weather, with a lot of instability, you have it topping out and creating what we call an anvil. So here's the anvil up here. Kind of this, I don't know if it kind of looks like an anvil to you. It's the flattening out part. We're going to call it something here in a minute, but can you see where if that elevation is the tropopause, kind of the lid to the troposphere. Can you see this little feature up here? It's kind of like a little hat, okay? That, what's that?
It's a yarmulke.
Looks like a yarmulke. It actually is what we call an overshooting top. And if you get an overshooting top, that means basically your instability has punched through the tropopause into the stratosphere. So that's in the stratosphere up there.
So when you get that overshooting top, that's when it gets really bad, basically?
When you get that overshooting top, you should know that you have a lot of vertical development. So you have cloud, 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 overshooting top. And you could have a number of options there. It could just be a normal sort of thunderstorm, okay? Or it could be a supercell, okay? But you have a lot of vertical development.
So you don't recommend staying outside?
I do not recommend staying outside with overshooting tops, no. Not around here.
The rain is so fun. So much better.
So this one, there's three stages. So this is the third of 3 stages, and this is the dissipating stage, okay, and it just kind of peters itself out. So notice that we still have a downdraft. Okay, so cumulus stage we had an updraft only, mature we had updraft and downdraft, and dissipating we only have a downdraft. And so the deal with the downdraft is it's created actually because your liquid water is pulling through your clouds, and they have a drag, and they're actually creating kind of a little bit of wind as they go through. So that downdraft is created by your precipitation. Very good. Cool, cool. So, we've all experienced the whole tornado watches. They're put out by different organizations than the tornado warnings. Of course, the tornado warnings make our adrenaline pump a little bit faster. The warning means, as you probably already know, like the video said, that they've seen it. Okay, it is actually coming to your area, a place near you. That's the warning. The watch is just, it's kind of some folks saying conditions might spawn severe weather. So, they put out warnings when one of these conditions is met. You got wind, 58 miles per hour or greater, okay? You got hail, 1 inch, okay, or larger. And that used to be different, I think. I think they're more liberal with it now. You got, if your cumulonimbus cloud has known to spawn tornadoes, they'll put out a warning and tell the warning area, they can see their trajectory and stuff. Although tornadoes can give us some, kind of go where we didn't think they were going to go, probably. So, but one of the things that kills people a lot, and this is why, yes, go in if you see, actually if you even hear the thunder, that means that the bolt of lightning that created that thunder is close enough to get you. And karma, what's that?
Gotta count down, don't you?
Yeah, you can count down, but if you can hear it, it's close enough.
When we have to umpire, you count the seconds when you see the lightning bolt, and that's how many.
When you umpire, yeah, but so when you umpire, do they wait a little while?
You have to wait 30 minutes. Once you see lightning, you can hear it and still go.
Really?
Yeah.
Okay, well, don't do that. I guess I have heard that, and I've heard some. I don't know if you've heard people complain about it, or are they okay with it?
Normally, they want to get it done and over with because all the parents don't like the rain.
Yeah.
So.
Yeah. So severe warning will go out with wind, hail, or tornadoes. So we are going to talk more about these multiple cell, like the squall lines of thunderstorm cells. Okay, but again, thunderstorm cells will still have those cumulus, mature, and dissipating stage. And up here it says, all right, when they gang up, a squall line of thunderstorms, it's almost like they kind of help each other. It's almost like they have a, I don't know, personality. They're out to get you. So this actually is an image from a top of a cloud. Can you kind of see the overshooting top?
Mm-hmm.
You can see
like
the
a mountain peeking over to the bottom.
Mm-hmm, exactly. And so you can see there's the overshooting top, and you can actually see it kind of flatten out, the anvil portion. And down there somewhere you are, right? Okay. So I'm going to kind of talk you through something you might have heard that we don't have to talk about, this capping inversion. And this capping inversion can get into place and kind of create conditions that give you these kind of all of a sudden thunderstorms. The lifting mechanism is kind of basically that warm, moist air has been capped by cool, dry air. And so on the next slide, I'm going to show you that that actually the sun does its thing, and so that warm, moist air gets unstable and it rises, but it can't go past the capping inversion. And so the last but not least, okay, this is the same, and this is the third in a series of 3. So you see, maybe it's the third in a series of 4, but an updraft. So what stage would this be in?
No.
What do you think? Do you see a downdraft?
The first one, I can't remember what it's
Right.
called.
Yeah, the first one. Cumulus.
Cumulus.
Right, exactly. Okay. So there's this thing called wind shear, and by definition, what wind shear means, and usually it's vertical wind shear, basically as you go up in elevation, the wind will change speed or direction, okay? And we know that wind changes speed as you go up in elevation. We've been talking about it for a couple of reasons. Like if this is the surface down here, we know that because of friction and because of pressure gradient force, actually your wind will be weakest down here. If each of my lines is showing like the longer line, meaning stronger wind, okay, we know that wind increases as you go up in elevation, right? That is wind shear. Wind is changing speed as you go up in elevation. If wind changes direction, that's also wind shear. So speed or direction. What does that have to do with thunderstorms? Well, here you go. We've got a couple of options. We could have a small amount of normal wind shear. Some small amount of normal wind shear is normal. Or we can have a lot of wind shear. So I'll kind of show you in the upper corners here. On the left, I'll show you normal wind shear and your cumulonimbus cloud, your vertical development, what that looks like. Okay, so if this is the bottom of my cloud, okay, you can kind of see, and actually this is with normal wind shear. You can kind of see the wind must be going at upper elevations kind of from left to right, okay, but this is normal wind shear. And actually this ends up with what we call a majestic cloud. Normal wind shear, majestic. Okay, so I could show the wind in here, kind of doing this. Well, if you see a thunderstorm that is doing one of these, and I bet you have, if this is my lifting condensation level, okay, and again the wind's kind of going from left to right, if you see it tilted, okay, like that, doesn't that even look scary? Okay, the reason that's tilting is because the wind shear is going like this. Notice how there's a lot more wind shear. Okay, this is what we call a tilted cumulonimbus cloud instead of majestic. And the reason it's tilted is because there is lots of wind shear. Now here's the deal. How do I say this? These guys are bad for 2 reasons. These are bad as in scary, or bad as in good, if you like kind of scary weather. One is that they can last longer. And I'm going to kind of describe to you in their mature stage, this guy's downdraft can get away from its updraft, so it doesn't squelch itself out. But the other thing, and it's listed down here, you see the NATO word, okay, rotation. Okay, with lots of wind shear over here, you can get rotation. When we talk about tornadoes, of course tornadoes rotate, right? And so this sort of wind shear situation can create what we call a mesocyclone inside of there. It's a big old blobby rotation thing that gives us tornadoes. So tilted is bad, scary, lasts longer, okay? Majestic kind of does its thing and goes
Majestic's the
away.
one you can go run in.
No,
Tilted is
because,
the one you don't want to go run.
well, if either one has lightning, do not go run. If it has
There are other
lightning.
plenty of color things around me.
Oh, gosh.
Rubber sole shoes.
No, that's a myth. The rubber-toed children are not going to save you.
I
Okay.
watched the guy get struck by lightning 3 times in a row on the internet. So, if he can do it 3 times, I can do it once.
They recorded and measured it 3 times in a row.
It happened, no, it was on a security camera.
Oh, okay.
Let's see what
I mean,
this.
he died after the 3rd one, don't get me wrong, but
Well, then you don't want to. Okay, so I guess it doesn't show inflow, but you see this, this right here. I'm going to go ahead and write the word inflow right there, and that's what we were looking at. This is inflow right here. So that camera was right here. Now, do you see, or watching this right here, do you see this right here? Okay. This is the anatomy of a normal thunderstorm in its mature stage. Why? Because we have an updraft and a downdraft. That downdraft is actually created in where you're going to find your precipitation. The updraft, it's going up into the cloud, so it's not precipitating there. This right here, if you were sitting on your porch right here, okay, you might have the inflow thing going, and then you're going to have the gust front going. So actually it's blue, I know, but there's no rain here. It's a gust front. Have you ever, right before a storm, pounds, you get this wind blowing out of the storm?
so
That's the gust
basically,
front.
if that guy, if he was standing there videoing and then all of a sudden the wind changed directions, he was about to not have a good time.
That's right. That is totally right. So that was inflow, and this is gust front. It has nothing to do with a weather front, but it's just a blow of air from the downdraft. Very cool. And you see a few other things. So that's the gust front. Shelf cloud. You guys see what looks like a shelf cloud? Isn't that adorable?
Yeah, until it becomes the thing that's next to it.
This is from a guy who wants to go running in a thunderstorm. So, yeah. So that's a shelf cloud. And the shelf cloud is kind of created by the inflow and the gust front. So it's kind of just jetting out there.
No, this looks like one that I wouldn't want to go run in, because it's all off to on the side of the top.
Overshooting tops. So I'm kind of thinking for your unit exam, I might go ahead and have a diagram, something like this, and kind of label some things. So the anvil, you guys see the anvil? Of course, it'd be right here, right? And they say that the anvil, sometimes I see an anvil on both sides, but the anvil will actually tell you the direction it's going. So this system is moving back right now. Points toward the direction the storm's headed. All right. So a few other features. So there I know it says roll cloud, but to me, this part, what we said before, we called it a shelf cloud, and you still can. Shelf cloud, boy, I can't spell cloud tonight. Shelf cloud, right? But kind of within the shelf cloud is a roll cloud. It's kind of like a hot dog. And you can kind of see how it's formed, because basically you have your updraft and your downdraft kind of going different directions. Kind of gives you a roll there. Roll cloud. All right. So we started out by talking just about regular old air mass thunderstorms. Okay, now we're going to take it up a notch and kind of introduce you to supercell thunderstorms. Okay, supercell thunderstorms, they're larger and they can last longer. So we got to understand, or got to try to figure how can they last longer. So supercells are something to really take note of. Almost all supercell thunderstorms will give you severe weather. in one way or another. Not necessarily all tornadoes, but you'll definitely, I would think you have damaging wind and hail and maybe even tornadoes with supercell thunderstorms. What's really bad is when you get basically supercells that are all kind of multiple supercells, and we've heard that before, I think, too.
What was that movie, The Day After Tomorrow?
Yeah, the movie The Day After.
The movie was awesome.
I like it too. So we talked about kind of the tilted cumulonimbus cloud because of wind shear. Basically, the wind's going really fast, okay? And so that actually can give you what I said a minute ago was like this kind of rotation. That blobby thing in the middle of a cumulonimbus cloud that can give you a tornado at the bottom is called a mesocyclone. All right. So meet a supercell. I know, you're like, dang.
That's complicated.
It is, but let's see how it's like a normal cell. So the red lines are the updrafts, or the
We don't
updraft.
have to label one of these, do we?
No, I can't see that as much. So the red is the updraft, okay? The blue is the downdraft. But what they say is basically and I've heard them say this in spotter training, the updraft wraps around the downdraft, okay? So that's kind of what's going on. And when we talk about tornadoes, I'll talk a little bit about the mesocyclone again. How does that thing get going, okay? So what else do we see that looks familiar? Anvil, very
Shelf.
good.
Overshooting top.
Shelf, overshooting top. Yep.
Rain.
So, rain, precipitation, yep. Exactly. Oh yeah, that's right, they do have a cute little tornado, which may or may not be there. And the tornado is associated with kind of the middle of the updraft, downdraft, the wrapped around updraft, okay? And that's the mesocyclone. So this is looking at, I count 3 supercells. Cluster of supercells. You look like overshooting tops. They look pretty big. Hard to tell, but they just look big. So that's from that's from looking down at the top, and actually this would be looking underneath the cumulonimbus cloud. So of course that little rope tornado is kind of what you see in the distance there. One of the things oftentimes you've been exposed to is if this is a tornado, which by golly it sure looks like a tornado, oftentimes they will have kind of what they call a wall cloud that has extended down from the base. So if this is the base of my cumulonimbus cloud, they'll have basically kind of a little chunk of cloud, and they tell you to look for rotation in that cloud. And look as you're looking down counterclockwise rotation in that wall cloud. And then kind of on dead center of that wall cloud will be your tornado. So I was just trying to kind of look here, and we'll talk about wall clouds coming up, but I was trying to see if there's, if I can see the wall cloud. I'm kind of thinking, it's hard to tell, but it almost looks like I see kind of a circular region there.
So there are always 2 wall clouds?
There aren't 2. But it's like a, I don't say
It's like a
cylinder,
ceiling.
a squatty cylinder.
It's like
right?
a drop ceiling.
Yeah, so it's like a circle. If you were to look up at it, it'd be like a circle, a wall
It's
cloud.
distinctly lower than the rest of the bottom of the cloud.
It lowers, and it rotates, and then you know you got something maybe coming from that wall cloud, maybe a tornado. So when thunderstorms gang up, there's 2 types of thunderstorms where there's more than one cell working at a time. And they are either a squall line of thunderstorms, okay, and let's see, squall line comes with basically a cold front. Basically, if this is your cold front, you're going to see radar here in a minute. Basically, they lift the warm, moist air in front of them, so you get little circles along that squall line. The other one is blobby, if you want to put blobby next to it, is mesoscale convective complex, abbreviated MCC. And the second one, okay, mesoscale convective complexes, they're great like in the middle of the night. Like have you ever had rolling thunderstorms come through about 2, 3, 4 a.m. and your dogs go crazy and you're trying to sleep? Okay, it's like thunderstorm after thunderstorm after thunderstorm. That's a mesoscale convective complex probably. Okay, so a squall line. A cold front is your best bet to get a squall line of thunderstorms. Basically, remember what thunderstorms need is the lifting, and so a cold front gives you the lifting. But the other type of line that's great is those dry lines that we talked about in last unit. Where I bet you guys told me on the test, if you have a dry line, then that means you have 2 warm chunks of air, you have a moist one, so you have maritime tropical, and you have continental tropical. Continental tropical is doing the lifting. That's called a dry line. So this here on the right is actually a figure of a typical squall line of thunderstorms. What you're looking at is reflectivity. Radar, basically, you guys know that the red means the more precipitation, yellow a little less, green less. Okay. So squall line, usually associated with the cold front. We talked about this type of cloud when we talked about cloud types. It's not one of the 10 main types, but it's called the momentous clouds. And it can be like on the underside of your anvil portion. Okay, so this is actually on the underside of your anvil. And they're kind of pretty. So this is showing you 3 sectors of different air masses. You know, we talked about what CP stands for, continental polar, CT, continental tropical, MT, maritime tropical. So between the 2 warm ones, the continental tropical and maritime tropical, we have the dry line. That's kind of your 5th weather front. So that's a great place for basically that continental tropical air to kind of lift up the maritime tropical air in front of it. So that's a dry line. So this actually, we're going to talk about kind of outbreaks. The word outbreak, you're like, oh, that can't be good, right? So if you have an outbreak of tornadoes, okay, associated with thunderstorms, okay, that's actually the real deal over here on the right. Now, I was looking at this at my office, and I was kind of like, oh, how do you know that this is a dry line? Let me pick blue. Dry line, question mark. Well, remember that we talked about this earlier in the class. You can pick any one of these icons. The top number is the current temperature. So the one I circled, that's 52 degrees Fahrenheit, right? Current temperature. 25 degrees, the dew point temperature. That's pretty low, so that means the air is pretty dry. So this is actually very dry air. Okay. If we compare that to this one right here, okay, the current temperature was 66. The dew point temperature is 64. That means it's very moist. You only have to go 2 degrees before you go ahead and get condensation to begin. Okay, so there is your dry line between those 2 warm air masses, dry and moist. And so the dry one does the lifting and the moist goes up and over, and you have a lot of instability there. So basically, it's not shown here, but if we were to have like a, let's see, what color should we look? I'll pick purple. So this right here, I'll put it kind of in advance. Those little circles looking down on them, those could be actually individual thunderstorm cells. So that's how that works. Squall line.
Wouldn't the isobars be a lot tighter than that, though? If there's like thunderstorms, or not thunderstorms, tornadoes?
Not necessarily. For the surface map, I don't think so. Yeah. Have you ever, like, to me, the tornado warnings, oftentimes they happen in the creepiest, stillest times if you go outside and you have a front coming through, you actually can have kind of calm wind. I don't know if that answers your question, but yeah. I guess I'm not surprised. They're not. I don't think you always have to have wind. The wind that the gust front, maybe this helps too. The gust front, that's actually not an isobar issue. The gust front actually is the instability, and the gust front is created by the precipitation in the downdraft. So you're not going to see those, we call that vertical wind actually, instead of horizontal. You're not going to, or it's vertical and then it's horizontal. But you're not going to see that in your isobars. I hadn't thought about it, but that really just doesn't show up. I'll have to try to pay attention.
Probably what happens is the pressure is normal up until it's on top of you, and then it'll spike.
Yeah, I don't think so, because I just think that instead of surface pressures giving you wind like we're used to, tight isobars on surface pressures mean you're going to have a lot of wind. It's a different dynamic giving you the wind. So mesoscale convective complexes. We'll do this and then we'll take a break. So those are the blobby ones, okay? And those are the ones I said are notorious for at night. Basically, I think they kind of just...
Never end.
Yeah.
Best ones, 'cause you can sleep.
Yeah, I like them. Our dogs don't like them, though, so...
We had a nice little thunderstorm last night.
That's what I heard. We didn't have it, so I'm glad.
It started at like 3 o'clock in the morning.
Yeah, we didn't get that, those thunderstorms, so lucky you. So kind of over there on the right, you can see, this is a different image. This isn't radar. Actually, this is one of those satellites, weather satellites, okay, that orbit the Earth. And so this is taking cloud top temperature. So the way this works, you guys remember the overshooting tops, right? If you see overshooting tops, you know that you have some basically deep sort of clouds,
Something
right?
not fun is going on.
Right. And so basically the cooler the cloud tops means you have overshooting tops. So that is actually what that's doing. So can you kind of see how big that is though? Like if you can see the states.
I can see Illinois there pretty easily. Illinois, Indiana, Michigan.
Yeah. Yeah, Illinois, Iowa. Okay, so they're really pretty big.
So basically that one is about as big as Iowa.
Yeah. And it looks like one, but there are, I'll show you here, there are lots of little cells at work. Okay? So mesoscale convective complex have lots of little cells working. They're not organized like a squall line of thunderstorm cells, but they're blobby. That's why. And as it turns out, actually, and this is where I said they kind of gang up, if you think about it, what this figure does is kind of show kind of side by side cells at different stages. So they still have the 3 stages. So try to look for the cumulus with just an updraft, mature with updraft, downdraft, dissipating with just a downdraft. So you can kind of see that kind of in the front from the left, that's the oldest cell, and the cell 3 is the newest cell. Okay, now in the 10 minutes later, cell 4 is the newest cell. You kind of get the idea. But they kind of feed on each other. They help sustain each other. So to get a good mesoscale convective complex going, for several hours and to kind of move, it needs to have a lot of energy. It needs to have a lot of moisture, warm, moist air. And I did a little bit of checking on this nocturnal low-level jet because I thought I understood it more than I apparently do. This low level really means low level for one thing. It's definitely not like the 2 jet streams we talked about, the polar jet stream and the subtropical jet stream. Those are like pushing the near the tropopause. Okay, this one's low level. So anyway, something that can happen in the spring and summertime is the formation of the nocturnal low-level jet stream that can feed these things warm, moist air. That's my point. All right, so that's a good place. We'll pick up here. another exciting topic, after break. Break time.